we can pass to the monitoring for the sustainability of the monument, which will be presented by Dr. Maria Karoglou. She is a member of the scientific and teaching staff of the NTUA. And what she will present is what we have already published for the monitoring of the monument. It's a teamwork along with Professor Mouzakis, Professor Pandazis, and of course under my surveillance. So I will ask Maria Karoglou to present it. Maria, you are having the floor.
Thank you, Professor Moropoulou. Can you hear me? Let's start with this. Can you hear me well?
Yes, we can. Yes. Very clearly.
Thank you,
Good,
Manolis.
Maria. You
Okay,
proceed.
so I will start with the presentation. As Professor Moropoulou mentioned before, this is the result of a multidisciplinary work team. So we worked 3 groups from the NTUA regarding the monitoring equipment and system, the Department of Chemical Engineer, the Department of Civil Engineer, with Professor Moropoulou in charge, of course, the Department of Civil Engineer with Professor Mouzakis in charge, and with the Department of Survey Engineer with Professor Pandazis in charge, correspondingly. Okay, let's move. When we talk about the sustainability of the whole Edicula, we have to put it in the context of the preventive conservation of it, which means we have to have in mind all the measures and actions that are needed, aiming to avoid and minimize future deterioration or loss. So all these actions need to be carried out within the context or on the surroundings of the monument. 7 crucial points of the preventive conservation. When we talk about prevention and conservation, we have to keep in mind is that we have to think as a member of a group and not individually. We have to think about the whole site of the monument and not only the object. We have to think about, we have to have long-term thinking and not short-term thinking to communicate all these ideas and with the public, and not to think only the whole Edicula, like for example, but the whole temple. And instead of thinking how, we should think why we are taking all these actions. So it's very crucial to consider what we need to monitor and why. Of course, this is where the risk analysis is coming. And when we talk about risk generally can be defined as the chance of something happening that will have a negative impact on our objectives. Every time we think about risk, we have to consider both its chance of happening and its expected impact. There are 3 types of risk occurrence. There are rare events, and when we talk about rare events, there are events that occur less often than about once every 100 years, like floods, damaging earthquakes, large fires, etc. We talk about common events that are occurring many times per century. And we are talking about also cumulative processes that can occur continuously or intermittently, like the corrosion of metals or the decay of materials, for example. So concerning cultural heritage, the main categories of risk in general can be like that, like we're talking about the climatic conditions, like incorrect relative humidity of the air or incorrect temperature. We're talking about the effect of light and UV, the different pollutants, the pests, the water in all forms, the fire risk, the criminals, or physical forces like the system risk. And the monitor in the whole risk management cycle, we can see it like the beginning or the end of the cycle. So once our risk treatment plan is implementing and the risk reduction measures are in place, it is important to check regularly how they are performing over time. If necessary, we make changes to improve their results, because risk management is a continual process and we should keep repeating the cycle and stay alert for significant changes that may occur. This can be changes in the context of the heritage asset or in our value assessments. There is something else we must learn to do at each step of the risk management cycle: document our work carefully. So, structural health monitoring is a part of an integrated cultural heritage management system for the restoration of a listed structure used to measure and evaluate changes over time by collecting and analyzing data. The effectiveness of a management system is ensured through identifying or predicting weaknesses which act as warning for implementing corrective measures. A new term is now applied. It's called civionics, which combine electronic and civil engineering tools. Monitoring is a critical and continuing process in the management of civil and construction management cycle for the issue of sustainability. For the structural health monitorings, there are different sensor networks that are used, installed on bridges, tunnels, dams, railways, etc., that in order to collect spatial and qualitative data on their response. These systems are capable of raising multidimensional alarms and the visualization of results in real time with high accuracy. Data acquisition is continuous and records are transmitted to central servers or clouds for elaboration. Continuous collection of data over several months or years reveals trends in the behavior of the structure and its evolution, helping to ensure its sustainability. So an integrated monitoring system should not only collect data related to a specific natural or man-made hazard, but also take into account environmental conditions at the site to which the structure is exposed and affect its vulnerability. So through monitoring, it's possible to conduct this assessment of the structure, including information related to the location, design, building materials and components, construction technology, previous intervention uses, and so on. In the literature, there are different sensor networks that are applied to monitor cultural heritage structures. So take into consideration that the external environment such as climate or the location cannot be changed, the building performance can be modified through suitable actions and operations. Now we'll present you the results already published of our work. You can find the exact publication. It is in the Structural Control Health Monitoring Journal concerning the Holy Edicula. I guess until now we have a lot of information concerning the monument itself, so I will not be so explanatory in this. But it's important to understand that the Holy Edicula is situated inside the Church of the Resurrection in the old city of the Jerusalem. And for ensuring the sustainability of the Holy Edicula, continuous as well as periodic monitoring using advanced equipment is crucial. So the Church of the Holy Sepulchre has undergone many cycles of rebuilding and renovation over the centuries to repair damage from fire, earthquakes, and war. These are two images before and after the rehabilitation works in 2017, when the permanent equipment for the monitoring was actually established. Main risks concerning the monument were the seismic risk, the rising dam phenomena, the bigger amount of tourists, and the climatic conditions of Jerusalem. So it was decided as permanent monitoring equipment to have special instruments in order to record the changes of air temperature and relative humidity inside the Holy Edicula, inside the temple of the Holy Sepulchre. Also sensors embedded in the menstruary in order to measure the menstruary temperature and materials moisture content. For the seismic risk, there were we were actually installed accelerometers for the earthquake response, and also a station for the spatial position deformation of structural elements. Regarding the monitoring of climatic conditions and materials moisture content, we have to say that the climatic conditions have the largest and least controllable effect on historic buildings, such as churches, which in many cases have no central heating and cooling system like the Holy Edicula. So the sustainability of a historic structure and its vulnerability to potential risk is strongly affected by its surrounding environment. This is very important. That's why we collected data for the city of Jerusalem. We can see for a year the changes of temperature and relative humidity of the air. So in general, the annual mean temperature of Jerusalem is about 17 degrees Celsius, while the annual mean relative humidity is really high. It's about 72%. So the high level of air relative humidity is a potential hazard to the sustainability of the Holy Edicula, since several phenomena leading to material deterioration will occur, such as water absorption by hygroscopic salts, high amount of physical water absorption, development of biodegradation products, etc. In order to record the microclimatic conditions inside the temple, we actually installed a wireless sensor system. This system consisted of small sensors. You can see here the different positions, like this. You can see here the sensor. So we have a total of 16 little sensors that were installed inside the Holy Edicula, but at the area around also the monument. And this actually communicate with gateways, and you can have with the cloud in your laptop all the relevant values for the air relative humidity and temperature. Moreover, we installed a second system concerning the measuring temperature and the moisture, materials moisture content. This plan is not so good, but we can see the different positions. So these sensors are of different type. You can see that they have also wires. So it's a hybrid system. The sensors, they are based, the function on capacitance of materials. So this is it's called a tape capacitance sensor. It's about 25 centimeters, and you put it inside the mensuary. We can see here in the photograph picture here. So they are connected with the data loggers, which record the data per hour, and also then we can have wirelessly the data and process it in the cloud in our office. A little about how they actually we put it in the mensuary. So we will actually, during the rehabilitation works, We put it in the sensor inside the measuring, and we close the specific sensors with the use of the mortar. And then we fixed the cables and we had all this connection. And concerning the results, we can have figures like this. This is, for example, very easily, we can actually compare the values of temperature inside the measuring, this curve, what is happening around the Holy Edicle, and what is happening outside in Jerusalem city. So we have a clear idea what is happening, because we don't have, as I mentioned, another cooling or thermal source inside the temple. So it's, we can see how the monument reacts to the effect of the external conditions of Jerusalem. And in a way, it follows the pattern of external temperatures, while for relative humidity, we can actually observe that inside the temple, we don't actually reach very high levels of relative humidity, while, as I mentioned, the air of Jerusalem actually have really high values of relative humidity. But inside the temple, the area around the Holy Edicle, the temperature range is between 40 to 60%. And this is the result from the sensors embedded in the inside the measuring regarding the moisture content. You can see different numbers, DMS, for example, 003 to DMS 011. These sensors were put in different heights, so we have an idea what's happening from the foundation and until the roof of the monument, so it's different heights. So we can see here that the highest percentage of moisture content is at the entrance of the ground level and in the foundation of the monument, while the lowest percentage is on a height close to the roof of the monument, which is very logical, since rising damp is the main cause of increasing the moisture content of material. So the moisture content of the masonry decreases as the height of the masonry increase. So the idea was to elaborate all these results from the sensors and to develop a hydrothermal simulator in order to control and manage an acceptable level of safety, sustainable thermal equilibrium, and to evaluate the daily, seasonal, and long-term conditions of air and well, propose an appropriate operation of the air conditioner system towards a hygienic environment, discover a possible risk regarding air conditions, and forecast undesirable and dangerous wall conditions. Let's pass now to the other system, which is the dynamic monitoring of the whole edicule. So the dynamic monitoring, it's about continuous measurements of the dynamic characteristics of the whole edicule and structural health assessment. Assessment of interventions in the environment, as well as any dynamic stresses on the behavior of the whole edicule. So we have monitoring of system behavior, trends, and continuous dynamic monitoring. For this, they were like 3 accelerometers. We can see here the positions that were set on the top of the roof of the Holy Edicule. And sorry, the two of them were on the roof and the other were on the foundation. And these three triaxial accelerometers are installed and connected with the recording unit. The power of the system was DC in order to avoid electric noise from the 50 hertz. Professor Mosakis can explain further if you need more details about this. And the record will be automatically digitized and saved in system memory. And the recording unit is connected to the internet as well, and the data can be elaborated by the authorized users. The parameter recorded and analyzed will be the free field acceleration of the rock surface and the absolute acceleration on two locations at the top of the structure. From the latter two sensors, the translational and rotational acceleration will be calculated, and consequently, the translational and rotational natural frequencies will be determined. Data will be analyzed in order to extract natural frequencies and the corresponding natural modes. Changes to the above parameters imply the occurrence of damages. So the lab accelerometers will be utilized for the installation of an earthquake health monitoring system to record the response of the Edicula of the Holy Tomb, and will provide the data pertaining to the safety and sustainability of the Holy Edicula. So this all data will be analyzed and correlated with earthquakes in the region and with data from other IDML sensors and instrumentation to provide an integrated understanding of the behavior of the rehabilitated structure. And since this data will be available, they can be analyzed in relation with other similar structures. And the other equipment, the permanent equipment that was used for the monitoring of vertical end movements of the Holy Edicula, it aimed to take continuous measurements in order to ensure vertically and detect any possible deviation of movements in time. So in order to monitor the inclination from the vertical axis or the monitoring of different movements. This is the example of a presentation of the deviation from the vertical of the reset columns at the north and south facade of the Holy Edicula in the Church of the Holy Sepulchre since time. That we can see here the differences from October 2016 to February 2016. And the periodic monitoring offers the following advantages. There are more accurate and reliable results through integrated least square adjustment. The estimation of relative displacements between consecutive time intervals, and the possibility to detect displacements of the site around the monument, and the spatial vectors of displacement of each measurement point can be calculated, and the accuracy and reliability of results can be assessed with statistical checks. While for successive monitoring are continuous monitoring of spatial information over shorter time intervals, real-time information, very small deformations of monitor points during restoration works, which act as a warning detector, outlier detection and relative alarm, capability of remote monitoring, results are expressed as diagrams of relative displacements between successive time intervals for each point in each direction, and scatter plots for the overall assessment of a displacement. This Professor Pantasis, if you need further information about the system, you should get in contact with him. So this is the total station. The geodetic network is set up and fully functioning, and consists of 17 points. So it monitors the structural deviation of the Holy Edicula, automatically transferring all data to the geophoto lab for better analysis. This is where the plan of the 3D geodetic network, the positions was decided to place for the spatial position deformation of the structural elements. 3 points are permanently placed at the upper stage of the rotunda at a height of approximately 7. This is not 7 point. Above the mean sea level of the folio Edicula. These central points were realized using special manufactured metal plates and tribucks in order to minimize or remove centering and leveling errors. And 10 points are placed on the roof of the folio Edicula. We can see here that how the tribuck looks like, and with a specially manufactured metal plate. And the mini prism on the roof of the Holy Edicula, this is like the 10 points, how they are on the monument. Here, you can see it. So we have different diagrams where present the changes of all the points position along X, Y, and Z axis. And we can see the displacements along X axis or the displacements along Y or Z axis for the different points, 13 points. And this is displacements of all the network points along this, for example, for x-axis. We can actually have an idea of the movement and the direction of the movement of the monument. So this is like all the horizontal displacements, for example, for a period from January to March. So for the point 11, for example, we have an average 4 millimeters that with the minimum or with the maximum value until 11 millimeters. You can see it here. And concluding, we can say that the structural health monitoring of the folio Edicula includes continuous and specific interval measurements of crucial indicators to ensure the sustainable protection of this unique monument. The monitoring plan developed by an interdisciplinary team provides the capability to take structural measures in case of changes to these indicators. The installation of innovative equipment records the response to the various hazards, such as thermohygrometric cycles, underground moisture, seismic activity displacements, and deformation due to settlements of shrinkage. And a series of alarms and awareness system is in place to inform the Christian communities which are responsible for the management of the Edicula and its visitors. Thank you for your attention. And if you have any questions, you can ask me.
Thank you very much, Dr. Karoglou, for the very thorough and in-depth presentation. If there are any questions, please, you might pose to Dr. Karoglou.
So everything is clear.
Can you govern the discussion, Maria?
Yes. I guess I don't know the background of all the people, so if there are any questions, don't hesitate to ask me. I will be very happy to answer.
Yes. Till we will have shared the next presentation, we have some minutes of time. If you could use them, I would be delighted. So, thank you, Dr. Karoglou. Everything was so clear.
Yeah, I guess.
There are no questions.